Malam.
Yo'q, hali boshlanmadi. Assalomu alaykum.
Если что-то очень непонятно, то можете сразу меня перебивать и спрашивать. Если есть какие-то вопросы, то я согласна в течение блока материала, пожалуйста, записывайте их, и после каждых 45 минут у нас будет время на вопросы, и тогда все эти вопросы мы обсудим, и я попытаюсь дать на них ответы. Я выключаюсь на английский. So this 3-day course, is a short introductory lecture and practical tasks course about CubeSat missions and small satellite missions. So at the end of the day, we'll know what is the CubeSat, how can we start thinking about small satellites, what types of the payloads are suitable for this kind of small satellite missions, and basically what do we need to know in order to start building the small satellite. The goal of today is to give the first overview on the small satellite technology, to provide some basic terms and to get acquainted with the topic, like in general, of small satellites, and also like to have a view on some mission examples. As a result, you will know what is a CubeSat and how, like, what information you need to start with a small satellite and what resources you can use if you want to know a little bit more about that. Regarding the structure, the course is a 3-day course with lectures and workshop. Each lecture day is split like between theoretical and practical parts, and during the practical parts we'll use some dedicated software for mission design, for orbit simulations, for budget calculations, and will like at the end of this 3 days course, you'll be able to know all the resources, like how to use all the resources in case you wanna come up with some CubeSat mission design. The theoretical part will consist of lectures, video materials, Q&A sessions, and I'll also have some quizzes just to get some feedback from you. And practical parts will be some research work, utilization of tools, and some calculations. So that practical tasks, they will bring us to some projects work, and in the end of the third day would be great if everybody, like, we'll split in the teams, and in the end of the third day we'll have a small presentation, a small competition for the best CubeSat mission scenario. Let's go quickly through agenda. So today, on Monday, there's a quick introduction to the course. We'll after that talk about small satellite recovery. We'll cover small satellite design specification, and we'll start with some basic satellite subsystems. We'll cover electrical power system on board computer. After lunch, we'll talk about message control and a little bit about propulsion. And we'll also start with practical tasks, small satellite design. And today we'll get an introduction to the project task. We'll talk about satellite mission design and analysis, and we'll end up with requirements definition for the missions for the practical task. Tomorrow, we're gonna continue with theoretical parts of small satellite mission history, and we'll see what missions were popular in the past, and what type of instrumentation did small satellites use on board. We'll also for specific missions and technology demonstration missions. So here we'll see what enables any kind of mission and what are mission examples in each of these domains. After the lunch break, we'll continue with the small satellite design practical task. This will include the architecture, small satellite architecture development, definition of subsystems, and we'll end up with some budget analysis. And during the last day, Wednesday, in the first half a day, we'll cover the big topic of launchers and separation systems. And there we'll see how to launch the satellite, how we'll review different launch vehicles, different separation systems. We'll see what is the best way to choose the launch vehicle or to choose the launch provider. We'll cover checklist for launcher selection. And as the practical task, we'll have some test and launch preparation tasks, as well as final presentation and selection of the best project. Yes, as I said already, so this is how the work packages in this workshop are distributed. We're gonna have the theoretical sessions regarding the design and technology part, and after that we're gonna implement that during the practical tasks. Basically, that's what the slides is showing, and in the end, you'll have the overall knowledge on the CubeSat mission design. Regarding the project, so with the knowledge you'll acquire, you'll be able to conduct A/B level study. So that's preliminary design review study, which is like the first and the second stages while preparing the CubeSat mission. So that covers the mission basics, requirements definition together with payload definition, subsystems definition, architecture definition of the satellites, and some high-level budgets and high-level analysis. Yes, a few words about myself. Yeah. My name is Daria. I'm working at Exolaunch in German Orbital Systems, based in Berlin, for already for many years. I have my background is electrical design control systems in my bachelor. My masters are in aerospace system management and mathematical modeling. I also waiting for PhD defense. So I finished my PhD studies in theoretical mechanics, and I'm looking forward to defend in the summer. And at Exolaunch, I'm working for almost 5 years so far. I'm responsible for mission design, project management, and I'm also leading the satellite development branch. Here, I would like to ask to get some feedback from your side. So what are your expectations from the workshop? So what would you like? As you are coming here today, or what would you imagine you will have as a knowledge in the end of the day?
We hope we will see some satellites, real one.
There are going to be many. Going to be many real satellites. Okay, thanks. What? Modeling. Okay, yes. We'll have some. Yes. What type of modeling?
For example, nano-satellite, modeling of nano-satellite.
Mm-hmm. Okay.
Okay.
Yes, we'll also have this. Anything else?
Как можно будет применять технологии?
Хорошо. Я думаю, что I think like project work, like in the project work, there would be like you can really study that during the project work. So like from the application perspective, that would be cool. Anything else you would expect?
For the collaboration.
Of course.
Yeah, that is for sure.
Many plans.
If it was possible, about new call, Erasmus call.
Okay, this I can add maybe tomorrow or in the last day. Yes, it's like I'm more from the technical side, not from the organization. So I'm an industry representative, but I can contact the organizers and maybe add some information in the last day. Yes. Yeah.
Any other questions? Okay.
Okay, just maybe one more organizational thing. I would propose to have 45 minutes lectures blocks, then maybe 5-10 minutes questions, and then a small break.
Yeah.
So I think that would be optimal. Yes, from here, then I'll jump to theoretical session number 1. And first, like this, during the first lecture, I would like to go extensively through the projects we're having at Exolaunch. And I think that's really cool to get an overview what type of work we're doing and like kick off from there. So I would start with the background and introduction of the company. Then I think we'll make a small break, and afterwards today is going to be the talk about small satellite vocabulary, design specification, and until the end of today we're going to go through all the small satellite subsystems. And I'll start with the introduction, yes, of Exolaunch. Exolaunch was founded in 2014 by 2 former scientists of Technical University of Berlin. So basically starting from some intellectual property developed in the university, the company has grown quite big, and yeah, starting from the small satellites and small and easy separation subsystems. Today, we're more than 25 employees, and we launch with different rockets. Yeah, we developed quite a lot. Pretty much, we're a multicultural team. We're pretty young, and by today, our product includes satellite separation system services, and I'm gonna quickly talk about like all of them, about the work we're doing. So we'll provide ExoLaunch, GmbH. We provide launch, deployment, mission management, and integration services for customers in the new space era. That's mostly the small satellite providers. We have participated successfully in around 140 macro satellites and CubeSat deployments. On this picture, you can see like my colleagues and our team members. Basically, this container, light container, is one of our most successful projects. This is the container which we're using for CubeSat's installation, and this golden thing around it, like on the left, that's the upper stage, the fairing of the upper stage of the launch vehicle. And I'm going to talk a lot about deployments, separation systems, and launchers on the third day. So we'll get back to this points in the third day. And on the right picture, you can also see different types of containers which are used for different types of the satellites. We participate actively in the launch provision, and here you can see launch vehicle providers with whom we're closely working. We had one launch with SpaceX earlier this year in January. Was absolutely great. We're closely working with Roscosmos, and had quite many launches on Soyuz from Baikonur and from Vostochny and from Plisset. We also had a launch with Arianespace from French Guiana and Rocket Labs from New Zealand. So all these missions had our deployment systems or our satellites installed. We're also in communication with Firefly and Indian Space Agency. So in upcoming year, we also foresee that we'll launch from India and once again from States, and we're also in communication with Virgin Orbits, where we also we're in communication right now. So we also see that we're gonna use their services, their launch services for our customers. Basically, we enable vision for new space leaders, for research, for institutions, for commercial companies, for governmental agencies. Basically, whatever company, whatever entity wants to launch the satellites, they're contacting us, and we cover all the necessary management, technical, and logistics and organizational parts of the job of bringing the satellite into space. We decided that we also manufacture separation systems, and I'll show them in the upcoming slides. Carbonics for microsatellites and exopods for CubeSats. We also developed the exoport device, which is separation system for launch vehicles. Yes, and basically whatever, together with the German Orbital Systems company, which is in charge of small satellite development, we basically cover all the life cycle, CubeSat-based or microsatellite-based mission management. In other words, if our customer has a mission idea or payload of whatever size, mass, or any other, any payload, they can contact us. We can build a satellite around it, and we can provide also the launch opportunity. Yes, and here on the right, you can see one of the pictures from September launch last year from Plisset. Also, like the Soyuz upper stage with the pairing with these containers around our separation systems. So the core of our business is the rideshare launch opportunities with the companies on the launch vehicles you've seen earlier, and the arrangement of comfortable orbit for our customers. We fly on low Earth orbit and sun-synchronous orbit most of the time, because that's the most popular orbit for small satellites, as we will see later. We also can do medium orbit, geostationary orbit, and we have a couple of customers who are interested in going beyond the geostationary orbit. But yeah, we're closely talking with them at this point. We believe that our separation systems are the most advanced in the market in terms of satellite safety, in terms of reliability of the separation, and we're constantly improving our designs. We're one of the companies who are providing the turnkey solution, which I already covered. So we develop all the hardware in the office. We conduct all the tests in the office, and we have history of 12 successful launches. Never had a problem with any of the satellites. And we have a lot of cool photos with launch vehicles. Yes, as I said, our core is the launch planning and launch provision. So we try to approach customers with a unique approach, where we try to find the best possible orbit rocket combination for every customer. We also provide mission management, which is adaptation of launch vehicle, adaptation of separation sequence, all the logistics around it. Our separation systems are available for CubeSats of different form factors, from 1U up to 16 and 24U, as well as the microsatellites. We provide the deployment sequencer mechanisms for launch vehicles. For example, if there are more than 100 satellites on one launch vehicle are launched at once, the rocket does not have enough interfaces to separate all the satellites one by one. So the deployment sequencer is an interface between the rocket and the deployers, while getting the signal from the launcher that the satellites shall be deployed at some specific moment. But our sequencer is in charge of correct deployment of each satellite in particular. We also conduct some licensing work. A lot of legal and regulatory, actually paperwork. For example, exporting and importing things to United States can be a little bit complicated. It's more relaxed when we launch, like from Russian launch pads. But we also take all this work on us, and basically our customers just need to deliver the satellite to Germany, which in most cases is quite easy to do. And from there, we cover all the necessary regulatory work to import the satellites together with launch equipment to the launch pad for final preparation for launch vehicle installation. We also conduct environmental testing, and here, this service is quite unique in the market. The way we do it, as soon as the customer has brought the satellite in Germany, we provide thermal vacuum and shaker tests together with the shaker test we provide together with the deployment deployer, which simulates the vibrational environment of the launcher in a better way for the satellite and for closer to reality. Basically, this test is closer to reality. Yes, and I'm going to talk about that, I think, also later. Shipment is another process we're taking care of. We have pretty much clearances, like the clearances we give out, they make it possible to process all the work worldwide, and we also are able to ship our equipment necessary for the launch organization in any country. We have all the licenses and all the clearances everywhere. And we ensure that the satellite reaches the orbit, not only the orbit, but also the launch pad itself. integration services. By that, like arriving on the launch pads together with the deployers and the satellites will also help integrating these deployment containers on the launcher, on the payload of the launcher, together with our customers. So as soon as the satellite, like as soon as yes, like our customers contact us, we can ensure them that the satellite will be placed on the launcher within the required time frame, and without any major risks for the mission. And the final one is the launch. As soon as we we have close contact with launch providers, and as soon as we receive any signal from the separation, so we're one of the first ones who receive all this data, and as soon as we have it, we share it with our customers for them to feel a little bit more relaxed about the separation and the contacts with the satellites. Yes, these are our missions by today. We started with Soyuz 2 in April 2013 from Baikonur. That was our first mission. We had, I think, 6 satellites on that mission. And from then on, we are launching regularly, pretty much every year. There was like 4 years gap between the first and the second mission when we were preparing the hardware in a little bit better way. So then 2017, July from Baikonur as well as the second one. And from there on, we also started launching from Vostochny in November 17, February 18, December 18, and so on. We had, the Rocket Lab launch in 2019 from New Zealand, French Guiana in 2019, also with Soyuz. Yes, and we had 3 Falcon launches in June 2020, August 2020, and January 2021. We're also preparing for one Falcon launch in June the next year. And this year, last year we also had a Desert, the launch from Desert Cosmodrome. Besides all of the launch parts of the business of the company, we also provide frequency consultation. We can assist in filling the application for ITU and getting the proper frequencies for the mission, and like UHF, SX, K bands. We also help getting proper frequencies for ground stations. I covered already the launch services. We also have technology transfer program where we can transfer some knowledge or some intellectual property for other companies. We conduct researches and studies on different scientific missions for our customers. We participate actively in proposals for new missions together with the European Space Agency. We have a university program, which I think this project is a part of. We give educational courses and workshops in the topic where we grew the most of the expertise. And the
Assalomu alaykum. Universitetda svet o'chib qoldi, o'shaning uchun ular ulanishmagan. Hozir ulab qo'yamiz.
Oppo, universitetda svet o'tsa ham Toshkentni sentrida.
Ovoz yaxshi kelyaptimi o'zi?
Assalomu alaykum. Yaxshi.
Yaxshi kelyapti ovoz.
Va alaykum assalom. Yo, narida hozir o'chib qoldi svet. O'sha kelsin sira yo'q boradi.
Bo'ldi, xabar.
Может позволить себе 2-3 года разрабатывать на 3 года и может никуда не превратиться. Если это какая-то коммерческая компания, то ей, конечно, нужно побыстрее компоненты не специализированные. сильно деградировали батареи. Но вообще 70% много. Если мы посмотрим, как мы компонуем аппараты, то установить дополнительные батареи может...
Иметь что самое быстрое батарея.
Да. Батареи, которые мы используем, они...
Электроника.
Электроника. С электроникой есть некоторые хитрости, которые позволяют защитить от радиации. Все-таки это слой металла, который есть вокруг, потом мы используем шилдинг, чтобы сохранить какие-то там флеш, память, например, или какие-то очень критические компоненты. И плюс мы используем некоторые софтовые решения для того, чтобы проверять какие-то ошибки. Плюс есть у нас защита от лачапс и так далее. То есть у нас есть механизмы защиты электроники с батареями. Да. И технологии эти примерно там есть разрядки, на самом деле Okay, let's continue. Yes, and in the place where we stopped after, yes, we also have university programs, which is this workshop is a part of. And upon request, we also do some engineering services, hardware systems, and software solutions, which include CubeSats, subsystems, small satellite subsystems, in general, space-related hardware, software products, as well as ground segments and launch-related devices. Yes, I'll go quickly through hardware solutions which we are proposing. So this device is called Exapod. That's a separation management device, which is an interface between a launch vehicle and several deployers. Basically, so this is how it is installed on the launch vehicle, and one of these cables is going to the basically the rockets to the launch vehicle. And from all the others, other connectors you can see here, depending on the mission configuration, depending on the amount of satellites, these are connections for the deployers. And as soon as the first stage with all the satellite assemblies is on the dedicated orbit, this device receives a signal from the launch vehicle that the separation shall start. This device counts the timings where each of the satellites shall be deployed. We cannot just deploy all the satellites at the same time, because there should be a probability of them crashing to each other. So in average, we have around like 30 seconds, 1 minute difference between the separations. So this device is in charge of this timing sequencing management. It might sound quite easy, so that the device is not super complicated to make. However, it has several redundant microcontrollers which are in charge of all these timing sequences. So this device doesn't have any chance of failure. Shall be absolutely reliable. Shall work after launch. The launch has occurred and so on. It shall also handle all the space environment, which is thermal, vibration, radiation, and so on. And as you might think, it's a simple and easy device to develop. This is quite complicated and costly thing. The big advantage of that is of our solution in So, this mechanism is spring-based. So as soon as the door is opening, the satellite is ejected in the orbit, and we'll also go through this design in more detail during the third day. Exaport is our next development. This is a big, this one, this device, like the yellow one, is the SpaceX provided port. Basically, everybody who's launching with the SpaceX get an access to one of these like whole ports. Yes, I think if you're interested in pricing, one of these ports costs $2 million to accommodate. And from our side, we have developed this interface, which allows us installation of our deployers as well as harmonic separation systems. These are systems for bigger satellites.
Zoom out notification.
And finally, from the deployment part of our company, the carbonics, so-called carbonic system, as a separation system family for bigger satellites and CubeSats. This is absolutely shock-free technology. Again, it doesn't use any pyrotechnics, which considerably reduces the risk of damaging some sensitive satellite components or some electrical components. It's spring-based. So basically, this spring is installed on the satellite on one side,